one administrative note before we start. Joe McManus is no longer
recording now.
Oh, you got it. Okay. So Joe McManus is no longer with Canonical. I'll be leading the working group with Kyle. We'll just continue moving that along. So with that, I think we'll just dig right in. And Mikhail, if you're good with just giving us an overview of how system tests work, I know we've had a lot of interest in that.
Sounds good. I'll give a shot at sharing my screen so that we can go through together. And if it doesn't go through well, we can just like find another way to do it. Up. Okay.
Hey, looks
good.
Can
you guys see my screen now?
Yep.
Perfect. All right. That's awesome. Yeah. So on a note related to that, but maybe we'll like discuss and make a decision later. Originally, all the test security stuff was part of this big package that was test communication, used for testing all the various configuration of communication in ROS2. And test security has been pulled out as a separate package, but keeping like most of the structure of the original package. And I think basically this working group are the only people like impacted by these tests and like following up on them. So maybe we'll see, but maybe it would make sense to move that closer to SROS2 or to a repository where the working group can act on it more easily and watch it more closely than a repo that's watched mostly by the ROS2 team.
And the dependencies don't cross between these packages, like it's suitable for actually pulling out potentially?
Yeah, mostly yeah, because it's based on that. We can have a look quickly, but so one thing that we could change among the many other things we could change is the fact that this is right now testing C++ nodes. Which is not that big of an issue, but so we have like a set of dependencies on RCL CPP, etc. We could also just make an RCL Pi version and keep like, if you want to move it closer to the SROS2 repo, like keep it in the same language. But overall, it's just depending on very common things, which is basically test messages and the ROS2 test infrastructure.
And to give an overview to folks who are probably, I mean, I'm not going to pretend to be super familiar with this. This is the whole reason Mikhail is presenting this. But correct me if I'm wrong, Mikhail. But these are essentially integration level tests, right? So we have individual security tests that are more at the unit level in the SROS2 utilities repo. But these are the things that actually make sure that security features work across DDS vendors and actually runs nodes and tests the communications. Yes,
that's exactly right.
Okay.
So the system test repo in ROS2 is for all the integration level testing, and so yeah, the test security is basically spawning nodes in different processes and making them talk with security and making sure that messages are coming across and messages that shouldn't come across don't, and that kind of thing. So we have basically like, let's say, two main types of tests there. One, which is mostly captured in this file, is making sure that configurations that should not work do not work. So we have a few of those. Some with like invalid key stores, making sure that if the key store is not recognized properly, then the various configuration of security strategies kick in. So basically, how it works right now in SROS2, if you say, I want to use security, you can then say, I want all the nodes I'm going to launch in that terminal to use security. And if they cannot use DDS security, they should not launch and not try to join the domain. Or you can have like more of a permissive mode, which is, okay, try to find security artifacts, use that to instantiate the security plugins. But if you don't find what you want, just start an insecure node instead. And so basically, and I guess that's part of why like the main like complex part is the CMake, but overall it's a bunch of text fixtures and factories which allow us to like parameterize all these tests. So the main things we're testing here is invalid key stores with a set of configs. So basically we say, okay, like here are the things you're going to pass as the key store pass. And so we have like some of them that are like, okay, this is going to be the key store path. This is use security or not. This is a security strategy. This is the name of the like enclave or participant. And so we have like arrays of these test configurations that are run one after the other. And so this is mostly to test all the cases that should not work. So we're basically expecting nodes to not work with those. And then we have a bunch of tests that try like a more multiple node level kind of thing. So we basically have a test secure publisher and a test secure subscriber. And these basically just spawn a regular node. And so on the publisher side, try to like reset all the environment variable and we try to publish. We have some configuration here on being able to test a variety of messages. The main goal of this and test communication was to be able to test all the messages in test messages. And this package test messages is supposed to be covering every possible configuration of ROS MSG files. So it's using every kind of primitive, every kind of nesting, multiple nesting, these kind of things.
Nice.
Currently, we test only a very small subset of that, mostly because it takes a long time. And so we cannot really afford to run all these because it would take forever. And so, yeah, here it's always the same configuration. We basically give it the enclave we want, which is basically the same by default. And then what is the name of the node, what is the name of the topic, and we just try to publish. On the subscriber side, it's more or less the same thing. We basically expect a set of messages to be received. So we subscribe to a topic. We trigger, like we get this callback instantiated that just gives us the messages that are received. And we make sure that basically we receive, all the messages received are part of the expected set. And so that we don't receive any unexpected message. And that's basically the main goal of this entire file. Then it has the exact same structure, just set of default arguments and possibility to instantiate callback for any kind of message. So all these are like fixtures, which is just like, okay, I expect all these messages when I subscribe to an empty topic. I expect all these messages when I subscribe to basic types. And that's basically it. Where it gets a bit trickier is that we want to be able to test this with all RMW implementations and ideally with all client libraries. And so to generate those tests, we have
this is what I wanted to see.
Yeah, so that's where it gets messy. And that's where I think I didn't have time. I was hoping to do it before this meeting because the current state of test security is testing only C++ nodes, and we're not doing cross-vendor testing, which mostly because up until like recently, I haven't tried recently, but up until a year ago, various DDS vendors were not able to speak to each other with security enabled. So I kind of like was hesitant on removing this ability because ideally we should be able to do that in the future.
So Michael, you know there is an interoperability test at the ONG for security, right?
Yeah, yeah. So actually, I mean, Ruffin is on the call as well. Like even if the interoperability tests were passing, so far we weren't able to get like this ROS level testing to pass. And I think the reasons are varied over time. There may still be an issue open. And Ruffin, like you looked into that, like, I mean, I guess it was 2 years ago, but up until a year ago, we couldn't get it working. Between RTI Connect and Fast RTPS, which were the only two that were supported, like they were supporting security and supported by ROS 2. And recently, I think something that may also be an issue, if I remember correctly, we had an issue with recent OpenSSL in Fast RTPS, and the fix for that has been for Fast RTPS to change the key exchange mechanism by default. And so I'm not sure if it's not matching the ones used by Connect, it will also not work.
Oh, well, I'm not aware about this issue. Maybe I will take them tomorrow with the team.
But yeah, and like if you give me a chance, like I didn't look at that for a long time, so like I want to be sure that I'm giving you correct information. But yeah, so I guess I can check, and maybe I've synced with Rafin as well that has been looking into that to make sure that like what are the issues we're facing today, not to point you to all the issues that may have irrelevant error messages. And I'll get back to you.
Sure, let's do it that way.
All right.
It might be worth if we. Mika, did I can't remember if you said you used to have the interoperability tests or if you were considering writing them.
No, so the logic, basically the logic, I wrote that logic for test communication that was not using security. And so, and then all that CMake logic has been copied over to test security.
Okay.
To the test security repo, like package. And so there is a CMake infrastructure to be able to generate cross-vendor tests. But we've never done it for security because empirically we couldn't get it to work, so we never enabled it for that.
Yeah, I wonder if it would be worth adding it just as an optional test. Would that be relatively straightforward? Just to check on it every once in a while, and then you can just give Jaime the output of that, basically.
Yeah, definitely.
Let's copy in the chat the ONG test for interoperability and security. And also in the agenda.
Yeah, so I didn't look at those recently, but I remember that's what we were basing on originally when we were testing with Rafin. Yeah, so I don't remember why we couldn't get it to work for ROS 2. And that's part of why I don't want to tell you it's because of that, because I may give you false information.
Another thing is, isn't it that some RMW implementations have slightly different mappings? Or was that ever? I remember like RTI had the built-in
the ROS built-in topics or whatever.
RTI handled services slightly different.
Yeah, I'm not sure that's the case anymore, but it was indeed the case where like RTI was implementing DDS remote protocol like RPCs, and so that's what was used for services, and it was not the case for OpenSPICE and Fast RTPS at the time. So basically, the RMW layer was implementing above topics the logic for services. But as far as individual topics are concerned, it shouldn't be impacting.
For cross-vendor testing, I think it might be nice if this test lived at least somewhat closely to cross-vendors testing of like non-security. So like you had two tests, one's that's security, one's that's non-security, and you get your full matrix and you can see like these two vendors work fine without security. So then you can narrow down your focus on why it's not working with security. But certainly we could still the ROS security working group could probably help take over the security matrix in terms of just testing SROS with security DS on a single.
Yeah, I guess that's like that was the original like thing. Like the test security were, I think, if I remember properly, like part of test communications to begin with. But because security needed so much boilerplate around, like setting more environment variables and stuff like that, And the fact that it was not the same people looking at these tests, I think at the time it was decided to put it in another package. So right now it lives close in the sense that I can see in the same repo, but it's not in the same package. So I don't know. It's kind of like a compromise between like having it closer to security features or having it close to other integration tests, and both are valid. So it's just like my only concern is that like I'm not looking at the CI jobs on a daily basis, the official ROS2 CI jobs, and so I don't get notified or I don't know when these security tests start failing, which is still the case with the current system, even if it's in another package. But now that we actually added that to the SROS2 CI, which is basically building SROS2 and building that package on top, that's when I realized that some of these tests are failing like every night. But I don't know for how long, because before we set up that CI, we didn't know.
And when we make fixes, we have to like beg them to get landed too. That doesn't help.
Yep, there is that too. And so yeah, now the really nasty part of this is that crazy CMake logic. And as you can see, like some of it is commented because it's actually able to do a lot more than what it's currently doing. But basically how it's working right now, it's looking for what are all the messages located in test messages and building a list of all the messages, all the services. And based on that, it can then do some magic. So we have like a couple sets of magic here. We have the C security test. So this is the first file I showed, which has like multiple testing configuration of nodes that should not be able to start properly. And so this is basically a function that is being called for each RMW implementation, generating tests, and then running them all. And that part, I guess I should go to the main logic before we go to that bit. And so how it works in general is that we find ROS2, we find SROS2. Based on that, we use SROS2 to generate all the security artifacts we're going to use for testing. And then once we created all that, and here we do a bit of a hack. So it's basically we're constructing invalid key stores. So here we're just removing a file from one of the enclaves to make the test fail. And here we're copying an invalid certificate into the valid certificate that was generated. And so these are just conditions to make the test fail. And then all the logic actually happens here. So there is this CMake macro provided by ROS2, which is just call that macro for each RMW implementation. And so if we go to the targets macro, what this does is first it's looking and setting up environment variables to be able to like use the right OpenSSL. The main reason is that ROS2 is using a pretty old version of Connext that doesn't have support for OpenSSL 1.1.1. And so we need to use 1.0.2. And here, this is the logic. And so this is where we right now say, OK, which implementations should be tested, like which ones are supporting security. And we call these two macros. So the one that generates all the C security tests. So this is the one I showed earlier. And then the bulk of the work is being done in the security test macro. And so what the security test macro does, it's basically defining. So we receive which RMW implementation is being used. So right now we kind of like hacked that. So that's where we disabled the cross-vendor testing, which is basically right now we use for the publisher and the subscribers the same RMW implementation, when usually we would do every cell of the matrix. And the same thing for the client library. Right now, we just set it to RCL-CPP, when usually you should be able to loop over RCL-CPP, RCL-PI, and whatever else if needed to test them all. And then this is where it gets very hard to read. So we have several test suites in there. The first one is testing that if we set all the right configuration of environment variable to disable security, do the nodes still speak? And so these are basically what these non-secure COM options mean. So we have here like 5 tests. And so this one is security enable on the publisher side, subscriber.
Wait, what did these match up to? Or no, I guess that's an array, isn't it? Okay.
Yeah, this is just a sequence. So basically what we're going to do later on is that we're going to loop over.
Okay, so as long as these have the same number of items. Okay, sorry, continue. I got you.
Yeah, there's a sequence of same lengths, and they need to have matching lengths. And so yeah, the first test would be security enable false for both, security strategy enforce for both, but it should be ignored because we don't use security. The key store should be, in this case, garbage because it shouldn't be used, etc. And then the next test would be these, etc. Then we have a test suite for testing actual secure communication. So here we say we want to use security. So security enable is set to true for all tests. And then we test the different. So we know that here we're going to be using a valid key store. So we're going to be able to find the security artifacts for every publisher and subscriber created. So they will all instantiate the security plugins. And then like we just play around with the strategy, which is basically if you can find the security artifacts, if you use enforce, it's going to work because what enforce does is like if there is a security artifacts, we use them. If there is not, the node cannot be created. And permissive allows you to have some missing artifacts and create not secure nodes. But here we're not gonna have any missing artifacts. So all these should end up with a publisher and a subscriber talking with security over a secure topic. And then these are the ones that are like supposed to not be matched. So this is basically a set of tests where like one node is using security, the other one is not. And so they should not connect. And so how it's done in the code is that we basically put a timeout and we make sure that we don't connect and don't receive any message during that time. And so these are basically the parameters used for the various test suites. And so then for each of these parameters, we're going to generate n files. And so in this case, what we're going to do is that we say that we're going to test only this subset of files. So we test only messages, and we test only the message types that are empty and unbounded sequences.
Whereas this macro is actually being called for every message in test messages, right? This is where you ignore all the ones you don't care about.
Exactly.
Okay, I was going to ask.
And so this is why like the C++ code, like all the rest has all the logic to be able to support every message type. And here we basically just whitelist a few of them and don't generate tests for the other ones.
In what sense does the message type have ramifications on the success or failure of security?
So it really depends. Like you would expect that if they all pass test communication, it should be fine. We had issues in the past where like depending on the order of the fields and if some fields were unbounded followed by bounded messages, like is the padding going to match? Is the length going to be good? Is the fragmentation, like is fragmentation going to occur?
But that's on the RTPS probably side of things.
Yeah, so that's part of the thing. Like you would expect that like if they all pass test communication, which is the one testing like just like communication between nodes regardless of security, this should pass here as well. But to be fair, like we always like I've been finding corner cases in like random failing tests in the past. So I think there may still be value, but for the last 3 years or maybe more, only these two types have been tested. So, and I guess in this case, like the empty type is not a very useful one because you basically just ensure that you receive messages, but you don't ensure the integrity of the data you receive. But we could test only one type, which is something that has a lot of data that we would need to match on the other side just to make sure that everything is working fine. Encryption, decryption, like you get the right thing on the other end.
Okay.
But yeah, so to be fair, like I don't know if we need to test more of those, and if like in what cases one message would pass and others would fail. So maybe we could just not have it, but I'm never sure because every time you write an extra test, you find an extra corner case that you expect it should work and should not be impacted, and for some reason it doesn't.
Well, there's something to be said for the fact that these are integration tests. They're not actually supposed like unit tests should be testing every corner case. I'm not sure integration.
For sure.
Yeah.
For sure. And I think that's part of why even on the test communication side of things, like only very few messages are being tested, because at the beginning it was also a way to ensure that both the message generators on the ROS side and the serialization on the various DDS vendor side were in agreement at the ROS2 level. But now that's been more or less like all the corner cases have been like fixed either in ROS2 or in the various DDS vendors. So there is not really a need for that anymore, except if you get a brand new DDS implementation that has a brand new ROS2 implementation across the middleware implementation, and then you may find some of these corner cases.
Yeah, that makes sense.
Yeah, and then basically what this does, so CMake doesn't have for loops, so we just do a while loop for a given number of time. And so here what we do is like we get the fixture from the list, the sequences above, and then we configure a test file with this information. So we give the test a name that is unique, and we configure this. Maybe I should have shown that before. Sorry about that.
Now you're using Python?
Well, actually, like originally, I wrote those. I mean, these are like launch files, so it's harder to write them in C++. But
Yeah, fair.
You don't want to. But yeah, basically what this does is like it's also now it's using launch testing directly. Okay. So basically but it's the same thing. You basically generate launch files. So you generate a test description. You just say which executable to use, any extra argument you want to give, which message type, which is an argument that the C++ executable take, should the subscriber time out or not, etc. And then, so as you can see, we don't do Python testing here either, and we just keep. So we extract all this from the fixtures. We put them in the environment of the publisher and the subscriber, and then we just say, add an action ready to test and launch this. So that's basically all it does. Then that's like just launch boilerplate that ensures that the tests are like properly exiting and this kind of thing. But on our side, all we're interested in is that like these tests that have their logic inside the C++ are launched. And so this is just generating launch files. And so, yeah, then we just repeat that. So we configure the file, we generate it, we increment because CMake is such a wonderful language, and we register the test, and that's it. And then what happens is that we do the same thing for the other test suite, and we do the same thing for the other test suite. So it's very verbose, but in the end, it's not doing anything very complex. And yeah, and all the rest, as I said before, is just like some magic to get the right OpenSSL binaries. And yeah, so that's basically it. So now if we talk about how we could make that readable.
I feel like we should all move to PyTest.
Yeah, that's kind of like my feeling as well, especially because like I don't see either a good reason for I mean, the only thing CMake gives us is the ability to generate stuff, and the fact that we already have like testing macros that give you like code for each RMW implementation and this kind of
Yeah,
stuff.
that was helpful. I didn't realize that was a capability we had.
But then on the other side, like you could, I mean, if you are willing to spawn a Python interpreter for registering and running your tests, you could do a very similar thing by just asking our CLPy which are the RMW implementations available, and then like loop over those to generate your tests. So
I mean, yeah,
I think
if the tests were already in Python, that seems like something you could do from the test itself, and then make I mean, that's essentially what you're doing, right? Is you're doing like a data-driven test generation thing. You can do that in PyTest too.
Yeah, so that's part of the thing. And then the other thing is that like right now, the executables are C++, but there is nothing preventing us from making a Python version. And at this point, except some CMake magics that I think we could still do in Python, which is just like invoking some commands, like some homebrew commands to find where OpenSSL is located, this kind of stuff. We could do all that in Python pretty easy as well.
Well, what would it? I have not tried this in ROS 2. So like in ROS 1, you always had that CMake list, right? Regardless of what language you were using. In ROS 2, yeah. Well, what that meant then was that it was pretty easy to sort of, you could kind of ship a node that used both ROS or that used both C++ and Python. What does that look like in ROS 2?
I think it's still pretty unclear. There are few packages doing that because one of the things for ROS 2 was to support pure Python packages, which allowed you to not have this magic.
Which I love, don't get me wrong, yeah.
Because that was one of the issues with Catkin. I mean, I've seen people deploying system with only Python, with people mastering Python and being completely lost because of the ROS one weird way.
Oh yeah, agreed.
Wait, if you want to install a script, you actually need to do that in CMake, otherwise it goes there on your path, but ROS run won't find it and whatever. And so one of the things that would be like that was an advantage of ROS 2 is to be able to say, hey, let's have pure Python packages. But if you want to generate messages, if you want to do like anything that is Ament, like all the cool stuff that Ament gives you, you cannot do it without CMake. So you cannot have the same problem. It's just like, it's been kicked down the road a bit, but I still see that as the same problem as before.
So if we wanted to run tests with Python but still use C++ nodes, how would we do that?
Well, honestly, like you would basically what you would do is that you would take this CMake list, delete 98% of it, keep the part that builds C++ executables, and then you would, like, you can register tests with Ament, like, I don't know, Ament test or something like that. Like, you can just do add PyTest, like add Ament PyTest or something like that. So you can register your test so that it would be run that way. And so the only part you would be needing between generating the binaries, the C++ binaries, and registering your test would be generating your test if you want to do it data-driven. And that part could be, if you want to do it in Python, you could just have one line of CMake, which is just invoke my magic Python script that generates my test.
So you could ship the CMake list and a setup.py, basically.
I think so, but in this case, the setup.py is irrelevant because...
You're right, I guess we don't actually need that, do we?
Because that's a test package. It shouldn't install anything.
Yeah, fair.
So we've run beyond our meeting time. I think it's a great discussion. I'm glad we actually captured it all. So we have it for later as well. I think it sounded like there's some potential to do some more work with the test routines. I think, Mikhail, kind of you pointed out a lot of opportunities there. So maybe that'd be something that we should pick up either on Matrix or at our next meeting.
Yeah, I agree. This was super helpful, though, Mikhail. Thank you. Now, I do actually feel like I understand what that thing's doing now. Thank you.
Well, I'm sorry. That's my bad because it's not readable because I wrote it poorly. So just like
No,
the least I could do is explain it.
It's not that you wrote it poorly. It's that I just don't know CMake that well. You know, you do. Definitely.
But yeah, so I'm very sorry for running over. I didn't look at the clock. I'm more than happy to follow up on Matrix, and we can decide, like, discuss both if we want to bring that closer to SROS2 to have a bit more control over it, and what tasks we can like split out of this discussion.
Yeah, sounds good.
That's great. Yeah, if there's any other notes that anybody we didn't get a chance to talk to, just drop them in the agenda and then I'll post them up. And Kyle, I guess we'll push off the SROS2 API update until our next meeting.
Yeah, sounds good. No problem.
All right. Thanks, everybody, for joining. Appreciate your time.
Thanks, everybody.
Thank you.
Thank you. Have a good one, everyone.
Thank you.
Thank you.
Bye, guys.
Thank you. Bye.
See you. Bye.